Hello everyone. Today we are going to discuss one of the very important topic, that is gravitation. So what are the concepts we are going to learn in this chapter? First is what? Universal law of gravitation, the concepts of acceleration due to gravity. Okay, what is the relationship between the small g and capital G? Okay, and we are also going to discuss the variation of g with the height, depth, we'll see. Okay, so let's start. First, universal law of gravitation. When we talk about universal law of gravitation, it was given by Newton. Who gave this law? Newton. So this is also called as Newton's law of gravitation. Okay, what Newton told, whenever there are two bodies, let's take there are two bodies, mass m1 and another body mass m2. So there exists a force of attraction between the two bodies in the universe. That force is directly proportional to the product of their masses. Okay, so m1 m2 are what? Masses of the two bodies, yes or no? And it is inversely proportional to the square of distance between them. Let's take the distance between them is what? R. R is the distance between the center of the two bodies. So what he told, there exists a force, okay, between the any two bodies in the universe. That force is directly proportional to the product of masses. It means when the mass is more, force is also more. Okay, and it is inversely proportional to the square of distance. Okay, inversely proportional means what? If the distance between them increases, force decreases, yes or no? So this is a universal law of gravitation. So once when you combine these two equations, can we write F directly proportional to m1 m2 upon r square, yes or no? Or when you remove the proportionality in physics, you have to put a constant. That constant is g m1 m2 by r square. This is the expression for force between any two bodies in the universe. Means force between the earth, moon. Even there is a force between my body and this table or benches or this room. It's any two bodies in the universe. Okay, here g is called as universal gravitational constant. G is called as universal gravitational constant. Okay, if you want to consider the unit of g, so g is equal to, from here we can write cross multiply F into r square by m1 m2, yes or no? So force is in Newton, distance square in meter square, and upon kg into kg, so become kg to the power minus 2. The value of g you have to remember, okay, g is nothing but 6.67 into 10 to the power minus 11 Newton meter square per kg square. This is very, very important. So let's see what is given. Okay, the force of attraction acting between the two bodies is directly proportional to the product of their masses and inversely proportional to the square of distance between them. Okay, fine. So mathematically we can write the force acts along the line joining the center of the two bodies. Where is the force? Force is along the center of the two bodies. Okay, now so we can represent F12 also we can represent force on 1 due to 2. That is also equal to F force on 2 due to 1, or simply we can write force F1 or F2. Means it will be attracted by this body with a force. Okay, this will be also attracted by this body with a force. This is a mutual force. Okay, so F1 F2 is equal to F, that is equal to capital G m1 m2 by r square, yes or no? So you can see here. Okay, the nature of force is what? Attractive. Okay, attraction. Okay, is it clear? If the mass increases, force increases, and the distance increases, the force decreases. Okay, now you can see mathematical derivation how we are going. Just now we derived so force of attraction between the two bodies F1 F2, that is equal to F, because both forces are same. Okay, so we can write according to the law of gravitation, force is directly proportional to the product of their masses, that is F directly proportional to m1 m2, and force is inversely proportional to the square of distance between them. So F inversely proportional to 1 by r square. So combining, if we can write F directly proportional to m1 m2 by r square. When you remove the proportionality, you have to put a constant. Just now I told G is nothing but a universal gravitational constant. That value is 6.67 into 10 to the power minus 11. Okay, meter cube kg per meter per second square also we can say. How we can say this? Now try to understand. Force is nothing but mass into acceleration. Yes or no? So mass is in kg and acceleration is what? Meter per second square. Okay, so this is 1 Newton force. Okay, if the mass is 1 kg and acceleration is 1 meter per second square. Okay, so we can say if the mass you can take 1 kg. Okay, and acceleration you have to take a 1 meter per second square. So this is 1 Newton. Yes or no? 1 Newton. Correct or not? So what I told, G is equal to 6.67 into 10 to the power minus 11 Newton meter square per kg square. So instead of Newton we are writing kg meter. Okay, the same unit you can write, just unit I am just showing. It is nothing but okay, so Newton we can write as what? Kg meter per second square. Is or no? And here meter square. Okay, meter square per kg. Okay, so you can see here meter and meter square become what? Meter cube. That's why you can see here meter cube is there. Okay, kg and kg into kg to the power minus 2, it become what? Kg to the power minus 1. Yes or no? And we can get a second per second square. So this also you should remember, not an issue. Okay, other unit. Okay, next we talk about the importance of universal law of gravitation. This question may be asked for 2 to 3 marks. State the importance, why we should learn. Yes or no? What are the advantages, what are the importance of the universal law of gravitation? So first one, you see the force that bind us to the earth. See, we are able to move on the earth, we are able to stay on the earth because of the force of attraction by the earth on our body. Yes or no? So that is a force which is binding us or any particle, okay, any living organisms on the surface of the earth. That is also okay, fine. First one. Second one is what? The motion of the moon around the earth. See, there is a gravitational force between the earth and the moon. Because of that, moon is revolving around the earth. So moon is the natural satellite of the earth. Yes or no? Next, even the motion of the planets around the sun. All the planets revolve around the sun because of which force? Gravitational force. Okay, na? And even tides due to the moon and the sun also. Okay, tides are also responsible. Okay, due to the gravitational force only. Why? Because moon is attracting the earth. Moon is attracting the earth. Because of that, the water is rising high. Is rising above the surface. Yes or no? That is only tide. Yes or no? So these are the 4 applications you should remember. Is it clear? Next, just unit of G. I told you SI unit of G, that is Newton meter square per kg square. Okay, and value of G you have to remember. This is very, very important. Either you can write a Newton meter square per kg square, okay, or meter cube per kg per second square. Okay. Okay. Now, how they may ask you define capital G. G is nothing but a universal gravitational constant. Yes or no? So what I told you, F is nothing but from the expression F is equal to G is equal to F into R square divided by M1 M2. Yes or no? So let's take a mass of each body is equal to 1 kg suppose, and distance between them is what? 1 meter. Okay, consider the each body is of mass, or from here also you can say no problem. F is equal to what? G M1 M2 by R square. Just now we discussed. What I am telling, mass is equal to unity or 1, and distance between them is also 1. So what we can write? F is equal to G into 1 by 1. So what we can write? F is equal to G. So what is G? How will define G? No, the G is nothing but how will define? If they ask you define G, universal gravitational constant. So it is the force. It is the force acting on the two bodies of unit masses. Okay, having distance between them is 1 meter. Yes or no? So that is G is equal to F. We can say G is nothing but if they ask you the value, you have to say this is the value. Okay, but if they ask you define G, so you have to write like this. G is defined as the force of attraction acting between the two masses, each of mass 1 kg placed at a separation of 1 meter. Okay, so this is the definition. You can note it down, very important. Okay, next let's talk about mass and the weight. Okay, so it's very, very important concepts. Most of the students are confused about the mass and weight. Okay, mass is the quantity of matter present inside the body, whereas weight is the force with which a body is attracted towards the center of the earth. Okay na? So let's discuss in detail. Okay, here mass. So the mass of the body is the quantity of matter in it. Okay, SI unit is what? A kilogram. Okay, generally in our day to day life we say what is your weight? We say 60 kg, 70 kg. Yes or no? So that is not the weight, that is our mass. We are saying wrong. Okay, from physics point of view. Okay, that is our mass, 60 kg. Is it clear? So, and CGS unit of mass is what? A gram. CGS unit of mass is what? A gram. Mass does not change with the location of the body. It is constant for a given body, and it is a intrinsic property of the body. See, mass of the body do not change with the places. Suppose when you are sent to the moon, or whenever we go to the moon, our mass do not change, but our weight will change. We will see in detail. Okay, what is mass? Mass is the quantity of matter present inside the body, whereas weight okay, is the force with which a body is attracted towards the center of the earth. Is it clear? What is the SI unit of mass? Kilogram. Next, now let's see weight. Okay, so the weight of a body is the force with which another body attracts it. Okay, generally earth attracts it. Our body is attracted towards the center of the earth. Yes or no? So with a force, that force is nothing but a weight. So SI unit of weight is Newton and CGS unit is dyne. How do you find the weight of the body? Try to understand. Okay, the weight of the body is said to be the force of the gravity on the body. Okay, so weight has a formula. Weight is equal to mass into acceleration due to gravity. The acceleration due to gravity value is what? 9.8 meter per second square. Or for simplicity, we are taking 10 meter per second square. So let's take the mass of okay, boy is 60 kg. Okay, so what is his weight? So weight is equal to what? M into G we have to do. So 60 into 10. If I am considering 10, so how much? 600 Newton. 600 Newton. If the mass is 1 kg, the weight will be 10 Newton. Mass is 10 kg, weight will be 100 Newton. 200 kg, the mass is 200 kg, so weight will be 2000 Newton. Is it clear? So from now onwards, if anybody asks you what is your weight, so if your mass, whatever your mass is there, you have to multiply with G. That is either 9.8 or 10. Is it clear? Okay. Next, we talk about relationship between the mass and the weight. Just now we discussed the weight of the body is related to the mass of the body as like this. Okay, weight is equal to mass into acceleration due to gravity. W is equal to M into G. So G changes from place to place. Remember one thing. Okay, so weight of the body also changes. Okay, for example, suppose a body is there, a person is there, okay, whose mass is there 60 kg on the earth. This is on the earth. So what will be his weight? Tell me. M into G, yes or no? So 60 into 10, that is equal to 600 Newton. Now whenever the person is sent to the moon, let's say the person went to moon. So what will be his mass? Mass will be 60 kg only, remember. But what is his weight? New weight will be there, what? Mass into acceleration into gravity, G dash. See, remember one thing, when at the moon surface, the acceleration due to gravity becomes 1/6 time of acceleration due to gravity on the earth. Okay, so in the earth, on the surface of the earth, it is 10. So on the moon, it becomes 10/6. Artha, so we can write mass is 60, G dash is nothing but G/6. G is 10, you can consider. Okay, so 10/6. 6 1 ja, 6 10 ja. So 10 into 10, how much? 100 Newton. So his weight, the person weight on the moon is what? 100 Newton. Is it clear? Yes or no? So this is how we can clearly see the difference between the weight and the mass. Okay, so here if they ask you in definition wise, okay, so how you are going to write this table, very very important. Mass is the measure of the quantity of matter contained in the body at rest, whereas weight is the force with which the earth attracts the body. Yes or no? Mass is a scalar quantity, okay, whereas weight is a vector quantity. Scalar quantity means it has only magnitude, no direction, whereas weight is a vector quantity, means it has magnitude as well as direction. Yes or no? SI unit of mass is kilogram, whereas SI unit of weight is Newton. Yes or no? Now its No, it is constant for a body and does not change by changing the location of the body. Mass of the body do not change. Okay, yes or no? On changing the location, whereas weight, okay, it is not constant. Okay, na, for a body, but varies from place to place due to change in the value of g. See, mass of the body can not be 0, but weight of the body can be 0. Yes, in a space, when we go to a space, acceleration due to gravity is 0. So what will be the weight on the space? In a space, okay, m into g. So g is 0. So mass into g means 0. That is what? 0. So weight will be 0. Yes or no? Getting my point, sir? So mass of the body can never be 0, but weight can be 0. Yes or no? Very important. Okay, so here just now as we told that we have taken the example of on earth and the moon. Same example is given, you can see here. Okay, weight on the earth is what? G into MEM by RE square. RE is nothing but radius of earth, M is the mass of the body. Okay, so R is the radius of the earth. Being a good student, you should remember radius of earth 6400 kilometer. In meter, how it is? 6.4 into 10 to the power 6 meter. Okay, yes or no? Radius of moon is approximately 1740 kilometer. Mass of the earth, how much? Approximately you can say 6 into 10 to the power 24 kg. Okay, and mass of the moon is approximately 7.5 into 10 to the power 22 kg. You can clearly see that earth is what? Approximately 100 times heavier than mass of the moon. Okay, earth is bigger than the moon. Yes or no? Getting not even radius of earth is what? Bigger, 6400 kilometer, and it is just 1740 kilometer, approximately 3.5 times. Yes or no? More than 3.5 times. Okay, so you can see this weight of the body on the moon is 1/6 of the 1/6 times of weight of the body on the earth. Directly you can remember this. Okay, fine. So weight of an object on the moon. Okay, so here you can, we have done this experiment also. If anybody is mass is 100 kg, so weight is what? 100 into 9.8. Okay, na? So how much it will be there? You can calculate also. If the mass is 100 kg. Okay, where? On the moon, sorry, on the earth. Okay, earth mass is there. On the earth mass is 100 kg. So what is the weight? 100 into 9.8. Yes or no? How much you will get? 980 Newton. Okay, if you send to the moon, on the surface of moon, what will be the weight? Weight is equal to m into g by 6 directly if you do. So 100 into 9.8 by 6. Yes or no? So we are getting how much? 980 by 6. 980 by 6. So you can cancel 3 times. This is 490. So you will get 162.2 Newton approximately. Okay, so we have done this experiment also. Yes or no? So very important, you should remember. Now I am going to explain you the free fall. Okay, when a body is falling freely. Yes or no? So, and what is the relationship between the small g and capital G both? Okay, very important. This question also may be asked for 2 to 3 marks. Okay, let's see. Relationship between the small g and capital G. Okay, try to understand. Let's take this is a body, this is earth. Okay, this is the earth, and mass of the earth is what? Capital M. Radius of the earth is capital R. Okay, now let's take another a body is there of mass of small m on the surface of the earth. Try to understand. What is the condition I have taken? This is the earth, R is the radius of the earth, M is the mass of the earth. Yes or no? And a body is there on the surface of the earth. Mass of the body is what? Small m. So can we write that there exists a force between them? Force is equal to what? Capital G, capital M, small m by R square. Distance is what? R. Now this body, whenever it is there on the surface of the earth, it will have a weight. Weight is equal to what? M into G. Yes or no? Correct or not? Let's say this equation 1, equation 2. Remember one thing, the weight on the body, okay, weight of the body on the surface of the earth is due to the force of attraction, universal force, Newton's force of attraction. Yes or no? So we have to equate the equation. Can we equate equation 2 is equal to 1? Why? Because this weight is due to this force. So both will be balanced. Okay, so we can write m into g is equal to capital G, capital M, small m by r square. Yes or no? So small m get cancelled. So small g is equal to capital G, capital M by r square. Now we know the value of capital G. Substitute it. Mass of the earth we know, radius of the earth we know. Okay, so from here we can get the value of G. If you solve, you get 9.8 meter per second square. For simplicity, we are taking 10 meter per second square. Yes or no? You can see here. Okay, G is the acceleration due to gravity at a place. Force on a body of mass m at any place. Okay, that force is equal to what? M mass into acceleration due to gravity, that is m into G. Just now we explained the force of attraction between earth, that is mass m, radius r, and the body mass m is what? This F is equal to what? G m by r square. Okay, now consider that the body is on the surface of the earth, means it is not on some height. Okay, so height of the body is far less than the radius of the earth, means it is just close to the surface of the earth. The body is close to the surface of earth, so that what? See, this height is very small compared to the radius. Okay, so we can write r plus h is approximately equal to what? R. Yes or no? That's why we can write okay, this one only, distance is what? R plus h, no, just r square. So both forces are same because of the body falls freely. So once you combine these two equations, compare the two equations, we can write mg is equal to, okay, capital G, capital M, small m by r square. This get cancelled, so we'll get the expression of small g is equal to capital G, capital M by r square. This derivation also very important. Okay, now what is the value of G? We got 9.8. Okay, here they have substituted also, you can see. Okay, the value of G you take, okay, small g is equal to capital G, capital M by r square. So small capital G you substitute, okay, with unit. Mass of the earth you substitute, okay, and r in meter, 6.4 into 10 power 6 meter square is there. If you solve this, you will get G value is what? 9.8 meter per second square. Yes or no? So G is called as acceleration due to gravity. Okay, yes or no? So on the surface of the earth, it is going to be same anywhere on the surface of the earth. Okay, see here, acceleration due to gravity is G for a free fall. The force with which the earth attracts a body is called as the force due to gravity. In a free fall, what happens? No change in the direction of the motion, there will be a change in the velocity only, that is acceleration due to the earth attraction. When a body is falling freely, you take any lighter object or heavier object, so both will have a same acceleration, that is 9.8 meter per second square. Yes or no? So this is the acceleration due to gravity. Getting so velocity will change with time. Okay, so as G is the acceleration due to gravity, so whatever that unit is there for the acceleration, same is for acceleration due to gravity, that is meter per second square. Okay, so here we have learnt problems are there in this chapter related to the when a body is rising up, going up, or coming down. Okay, some problems will be asked. So we are applying the equations of motion. We have three equations of motion right now. What is the equations? We learnt first equation, V is equal to u plus at. Yes or no? Here what happens? Particle is moving what? Vertical direction. So distance is replaced with h, height. Acceleration, when an acceleration is replaced with g. When a body is falling freely or going okay up from the surface of the earth, so acceleration due to gravity is what? G. Okay, when a body is falling down, so we have to take plus g. When a body is going up, we are taking a minus g. Okay, now so we can write v is equal to what? U plus minus gt. Yes or no? T is the time. Second equation, what we learnt? S is equal to what? Ut plus half at square. So s is replaced with what? H. Yes or no? H is equal to ut plus half plus minus half gt square. Yes or no? Okay, and third equation, what is there? V square is equal to u square plus 2as. So here also we can same equation, v square is equal to u square plus minus 2gh. Is it clear? Same, you can u square, you can take left hand side also. So velocity at any time is what? V is equal to u minus gt plus minus gt, you can take, no issue. Okay, but here is given for a body thrown vertically upward, when a body is thrown upward direction. So for upward direction, okay, upward direction A is equal to what? Minus g. Okay, so directly we can substitute V is equal to u minus gt. Height, what height it will achieve? Okay, so height h is equal to what? Ut minus half gt square. Okay, now yes or no? Velocity when the body reaches on the top, and the top what happens? V square is equal to u square minus 2gh. So at the top, whenever body reaches at the top, the velocity become what? 0. Okay, when the at the maximum height, the velocity become 0. So if you substitute here, substitute the value. Okay, v square is equal to what? You told v square minus u square is equal to 2gh. This is also correct only. Okay, so final velocity is what? 0. So 0 square minus u square is equal to 2gh. Is it clear? Getting or not? Okay, so we can do that also. Okay. So what is the total time required to reach at the maximum height? T is equal to what? U by g. Okay, T is equal to u by g. Why? Because final velocity is equal to 0. Which equation you can apply? First equation, V is equal to what? U plus at. Body is going upward direction. So V is 0, U is U only, A is how much? Minus g. Okay, A is equal to what? Minus g into T. Minus g, T you bring left hand side, so plus gt is equal to U. So T is equal to what? U by g. Yes or no? So this is the expression you can remember. Okay, and what is the maximum height? That is u square by 2g. From here you can see. Okay, from here h is equal to what? U square by 2g, the value. Is it clear? We will take the numericals, that time we will discuss. So this is all about the gravitation concepts. Okay, I hope you understood these concepts. Please watch the video and subscribe the channel. Thank you.
So when